This video is going to give a really quick introduction to the idea of continuous distributions, which are covered in Chapter 3, Section 5. Height in centimeters is shown in this histogram for US adults. And so if we wanted to try to figure out the probability that a randomly sampled US adult is between 180 and 185 centimeters tall, we could figure out what proportion of the data falls into the bins of our histogram that are in that range from 180 to 185. Now, one thing to recognize is that height is actually not a discrete random variable. It's a continuous random variable. Right? And so we could theoretically make these bins narrower and narrower until we had something that was a very smooth curve. So now, because height is a continuous numerical random variable, its probability distribution can be represented with what we call a probability density function, which is a smooth curve that has the total area under the curve equal to 1. And if we then want to find probabilities from these smooth density functions, these continuous distributions, we can do it by figuring out what proportion of the distribution is under this curve in the range of values we want. So in the situation of our heights between 180 and 185, we can estimate the probability that a randomly sampled US adult is between 180 centimeters and 185 centimeters tall by finding the area under this density curve between 180 and 185. And this is how we calculate probabilities for continuous random variables. We find the probability that an individual is within a particular range of values by finding the area under the curve between the two values. And one sort of interesting thing to note about these continuous distributions is that we define probabilities as using the area under the curve. And since if I choose an exact point, like 180 centimeters, any exact value, the area under the curve below an exact value, like 180, is 0. So we say the probability that a person is exactly 180 centimeters tall is 0. And that will be true for any value I choose. The probability that an individual will have exactly that height will be 0. And this is really because if we sort of think about this, there's an uncountably infinite number of possible values for height. And so the chance that we're going to have any one in particular is going to be 1 over this uncountably infinite number. And so we sort of think of that as going to 0. So with discrete distributions, we saw that there was positive probability associated with each of the possible outcomes. With continuous random variables, we use these smooth curves to model the distribution. The probability that the random variable takes on any exact value for a continuous random variable is always 0. And we talk only about the probability that the random variable takes values in a particular range of values. So again, just a short introduction to some of the concepts related to continuous distributions. And we'll be using a continuous distribution called the normal distribution a lot in the next chapter. Have a good day.